Today we'll be dealing about computer architecture. We'll be talking about why does the data path cycle have a huge impact on the performance of the CPU. So when we talk about CPU, it's a central processing unit of the computer. So the CPU is the main brain of the computer. Okay, so the data path cycle plays a crucial role in CPU performance because it determines how efficiently the CPU can fetch, process, and store data. Here is why it has a huge impact. Okay, latency and throughput. A long or inefficient data path increase the time into brackets latency it takes to move data between CPU components into brackets registers, arithmetic logic units, that's ALU, memory or etc. Slowing down instruction execution and reducing throughput. Clock speed dependency. The data path cycle length influences the CPU maximum clock speed. A shorter data path allows faster clock cycle, enabling more instructions per second. Pipeline bottlenecks. Modern CPUs use pipeline to process multiple instructions simultaneously. If the data path cycle is poorly optimized, it can create stalls or bottlenecks, reducing pipeline efficiency. Energy efficiency. Inefficient data paths increase the consumption of the CPU, leading to heat generation and reduced energy efficiency. How does the CPU fetch, decode, and execute instructions? The fetch, decode, execute cycle is the fundamental process through which a CPU operates to execute instructions. Here is a breakdown of each step. So we'll be talking about the fetch. The CPU retrieves an instruction from the memory. This process involves program counter, that's into brackets PC. The PC holds the memory address of the next instruction to execute. Instruction fetch. The instruction stored at the memory address in the PC is copied into the CPU instruction register. Increment PC. The PC is incremented to point to the next instruction in sequence, preparing for the next cycle. Decode. We are now on decode. The CPU interprets the fetch instruction to understand what needs to be done. This involves instruction decoder. The fetch binary instruction is analyzed by the CPU instruction decoder, which breaks it into its components. Opcode. It specifies the operation to perform. Example, add, stop, and load. Operands. It specifies the data or the location of the data. Example, registers and memory addresses. The CPU determines the resources. Example, arithmetic logic units, that's ALU, registers required to execute instructions. Now we are on the execute. The CPU carries out the operation specified in the instruction. This process may involve arithmetic logic unit, that's ALU. If the instruction requires mathematical or logical operation, the arithmetic logic unit performs the operation. Data movement. If the instruction involves moving data, it will transfer data between memory, register, or input-output devices. Result storage. The results of the operation is stored in a register or written back to memory, depending on the instruction. Control unit oversees the fetch, decode, execute cycle, ensuring all components work synchronization. Clock cycle. Each step may take one or more clock cycles depending on the CPU architecture. Example, single cycle versus pipeline processes. Pipeline. In advanced CPUs, modern CPUs often process multiple instructions simultaneously by dividing the cycle into stages.